Hello everybody, and welcome back to another PSAT Boys video. We still make them. So today we're looking at the science passage from the PSAT. So on the PSAT you have multiple reading passages, but one of them is always going to be about a science related topic. It's just like any other reading passage, you still have to answer the same types of questions. The passage is going to be about something related to science. And this time it's about lunar eclipses.
Nice.
So, we begin by reading the entire thing and highlighting the important parts. A lot of people will say you should read the questions first, and that is a strategy, but we found it's better to understand the passage completely first and then take sort of highlights and stuff so that it's easier to go back to it once you read the questions. So let's begin. Many people are aware of the beauty of a solar eclipse, but are surprised to learn that lunar eclipses are often just as spectacular and are both more common and easier to observe. The filtering and refraction of light from the Earth's atmosphere during a lunar eclipse creates a stunning color effect that range from dark brown to red, orange, and yellow. Each of these light shows is unique since they are the result of the amount of dust and cloud cover in the Earth's atmosphere at the time of the eclipse. While total solar eclipses last only for a few minutes and can be seen in only small area of a few kilometers, total lunar eclipses can last for several hours and can be seen over much of the planet. In fact, the beauty and stability of lunar eclipses make them a favorite of both amateur and professional photographers. Lunar eclipses generally occur 2 to 3 times a year and are possible only when the moon is in its full phase. When we see the moon, we're actually seeing the sunlight reflected off the surface of the moon. When the Earth is positioned in between the moon and the sun, however, the Earth's shadow falls on the moon and a lunar eclipse occurs. To better understand this process, it's helpful to imagine the Earth's shadow on the moon as a pair of nested cones, where the Earth at the apex of the cones and the moon at their bases. The outer, more diffuse cone of shadow is called the penumbral shadow, while the inner darker cone is called the umbral shadow. So we went through, as you can see, and highlighted all the important parts. So obviously we don't know exactly what the important parts are since we haven't looked at the questions yet, but we can sort of judge it just by looking at it what we think might be important. For example, things that would make easy questions would be related to, for example, colors or scientific explanations of things. So for example, each of these light shows is unique since they are the result of the amount of dust and cloud cover in the Earth's atmosphere. Since that's somewhat explaining a scientific concept, chances are there's going to be a question related to that. Further down here, where you see making them a favorite of both amateur and professional photographers, and the explanation of when the lunar eclipse occurs, these sentences you can see are sort of comparing and contrasting lunar eclipses to solar eclipses. So that's a really easy thing for people to make questions about. So whenever you see two things being compared, definitely take a look at that and keep it in mind, because chances are the questions are going to be about that. So let's move down to the first question. According to the passage, the colors of a lunar eclipse are the result of A, the penumbral shadow, B, the stability of lunar eclipses, C, the filtering and refraction of light, or D, the sunlight reflected off the moon. So let's look at what we have highlighted to see if we have something that relates to that. So as I said earlier, we highlighted all the colors because that's a simple concept that could make questions out of. So we can look at this sentence because we know that the answer to the question is most likely here. So this sentence says, starting from the beginning, the filtering and refraction of light from the Earth's atmosphere during a lunar eclipse creates a stunning color effects that range from dark brown to red, orange, and yellow. So these colors are a result of the filtering and refraction of light. Was that one of the answer choices? Look at that. It was. Answer choice C. And we can find that super easily because we had it highlighted up here, information that we thought might have been important later. So let's move down to the next question and see if we can do the same thing. So, question number 2 says, in lines 26 to 27, the phrase pair of nested cones serves to A. Offer support for the previous statement, B. Describe why the diffraction of light through the atmosphere, C. Explain why lunar eclipses are a favorite of photographers, or C. Provide concrete examples to help readers visualize a phenomenon. Alright, even though the line numbers aren't marked, we could still look if we highlighted something like a pair of nested cones because it seems like something we would highlight. So let's look. And look, there it is. Pair of nested cones. So let's read the whole sentence to get a better understanding of what they're talking about. To better understand this process, it's helpful to imagine the Earth's shadow on the moon as a pair of nested cones, with the Earth at the apex of the cones, and the moon at their bases. So this nested cones thing is a sort of analogy that they're using to explain the concept of why lunar eclipses occur. So does that seem like any of the answer sources? Offer support for previous statement. It's not offering anything supportive, it's just explaining something. So, B. So it's not A. B. Describe the diffraction of light through the atmosphere. It's talking about lunar eclipses and not light diffusing through the atmosphere, so we can cross that one off too. Explain why lunar eclipses are favorites of photographers. So that explain was something I was talking about. But there's no mention of photographers anywhere in this sentence, and it's just sort of explaining the concept of a lunar eclipse, and not whether or not that makes it more friendly to photographers. So we can cross that one off too. D. Provide a concrete example to help readers visualize a phenomenon. So by process of elimination, it's obviously D, but we're going to look back to make sure. So reading the sentence again, a pair of nested cones is, as I said, an analogy or metaphor used to explain to the reader how a lunar eclipse occurs. So nested cones is something you can visualize. It's just cones that are on top of each other. So that's something you can understand more easily than the actual process of a lunar eclipse. So it is a concrete example to help readers visualize a phenomenon. So it's answer choice D. It's pretty good.